Okay, our topic here is absolute value inequalities. Okay, so we've talked about solving absolute value equations, but not inequalities yet. Okay, and there are going to be two cases, so these create compound inequalities. And when you have a greater than or equal to, let's think about that. The absolute value of x is greater than or equal to 7. Okay, that means the absolute value of x could be split into x or negative x. Okay, let's look at that. And if obviously this is solved for the positive case. Remember how we split our absolute value into two cases? If you divide by -1, x would be less than or equal to -7. Okay, so this case, we're starting with a greater than, and we're ending with an or inequality. Okay, so let's graph that. X is greater than or equal to 7 would be closed circle, shaded to the right. X is less than or equal to -7 would be closed circle, shaded to the left. So this is an or inequality when we started with a greater than. Oh, which is right here. Greater than or equal to. Ends up being an or. It's shaded on the outside. And its interval notation is -infinity to -7 union 7 to infinity. Okay? So for the pretty much most part, when you start with a greater than, you're going to get an or inequality. Okay? Well, let's see what happens when we start with a less than. I'll use a different color here, less than. Okay, so let's see what happens there. When we split into two cases, we'll have the x is greater than or equal to 4. Excuse me, same one. Okay, or negative x is less than or equal to 4. So we either have x or negative x for your absolute value. Okay, this one's already solved. And then if you divide by -1, x is going to be greater than or equal to -4. Okay, so if we were to graph that, x would be greater than or equal to -4, which is this way. But x would be less than or equal to 4. Sorry, those should be closed. Which would be that way. And their overlap is in the middle. So that creates an and inequality when you start with a less than or a less than or equal to. Okay, so they're opposite. If you start with a greater than inequality, you're getting an or. If you start with a less than, you're getting an and. And this interval notation would just be -4 to 4. Okay? Now that may have been a little bit confusing how I solved that, so we're gonna solve it below with the KISS method. I'll show you what that is, okay? But what does this mean? It means when you get a greater than or greater than or equal to, your solutions will be or. Will be or inequalities, which means shaded outwards. If you start with the less than or equal to, your solutions will be ands, which means shaded between. Okay? So how are we going to solve those from here is not quite as complicated as I did it. There's a much easier way, okay? But first, just like when we solved the equation, we've got to isolate the absolute value. Get it all by itself, okay? Then we're going to create two cases using the KISS method. We'll keep it, switch, all right? I'll show you what that means. One case, you're going to keep the inequality exactly like it is. Then you're going to switch the inequality, switch the sign. Okay, then we're going to solve both inequalities and graph our solutions. And unless we have a crazy tricky one, if we start with a greater than, we should have a or. If we start with a less than, we should have an and. Okay, let's do a couple of these. So number one, our step one is to isolate the absolute value. It is isolated, it's all by itself, so we can do our KISS method, okay? So we're gonna keep it, switch, switch. All right, so this x plus 6 is not gonna change. That's still there. So we have x plus 6, and when we keep it, we keep exactly the same, greater than 7. Okay, that's your ki, and then your switch, switch, x plus 6 isn't changing, that in the middle stays. You switch the sign to the way you switch the way it opens, and then you switch the sign of your number. So if it's positive, you make it negative. If it's negative, you make it positive. So switch the sign, switch the number. Then we solve them separately, and we'll get our two solutions. So x is greater than 1, and then x is less than negative 13. Okay? Now we started with a greater than, so we should end with a or, unless we have some crazy like sign changes and they both point the same way. But for this one, x is greater than 1, open circle shaded to the right, and x is less than negative 13, open circle shaded to the left. That's an or. Okay, so interval notation, negative infinity, negative 13, union, 1 infinity. Okay, so that is a KISS for you. Keep it, switch, switch. Okay, none of these on the front page have something where you have to isolate the absolute value. Okay, so let's do 4, because I see a negative with the n there. Okay, so we're starting with the less than. Let's see what happens here. Our absolute value is isolated, so we can do our keep it, switch, switch. Okay, so when I keep it, the keep it is less than or equal to 27. The switch, switch would be greater than or equal to negative 27. Okay, that's the difference. You have keep it the same, exactly the same. That's a 2. And then you have switch, switch. Switch the sign, switch the sign of the number. Okay? Then obviously 7 minus 4n doesn't change. That's still there. Okay, and just like with an absolute value equation, we had 2 solutions. We have 2 solutions for the inequality also. Okay? So solve these. Subtract 7. Negative 4n is less than or equal to 20. Divide by negative 4. And n becomes greater than or equal to negative 5. Okay, make sure you switch the sign. All right, then for switch, switch, that case, we have negative 4n is greater than or equal to negative 34. Then divide by negative 4. And if it's a nice decimal, I am going to keep that a decimal. Because when we're graphing, it's easier to see 8.5 on the number line than a fraction, right? Okay, our sign needs to change the way it opens because we divided by a negative. All right, so now I have n is greater than or equal to negative 5, and n is less than or equal to 8.5. Okay, so let's do negative 5 is right here, closed circle. That's going to be shaded to the right, okay? But then let's just do it all together. 8.5 is right here, closed circle. And we want that less, okay? So any way you can think of that. If we start with the less than, you're shading in the middle because it's and. Okay, the only time that would change is hopefully it happens on the back. is if you're dividing by a negative and then your sign flips, then your rule would change, okay? But if you start with a less than or equal to, once it's isolated, less than is an and. So that should be -5, comma, 8.5 for interval notation. And notice the difference in these interval notations. Okay, an or has a union and a gap, and does not. Okay, that's it for the first page.